Welcome to the channel. Thanks for joining us, your one-stop destination for everything AI. If this is your first time, please consider subscribing and ringing that all notification bell. Upon reaching 1,000 subscribers, we will have exciting AI giveaways at our online store to help celebrate this special occasion. For over 50 years, NASA has pushed the boundaries of technology to enable humans to explore space. A key focus has been developing robotics to assist astronauts. These robots take on tasks too dangerous or tedious for humans, expanding what is possible in space. NASA's Johnson Space Center has been at the forefront of this research. This marked the beginning of Valkyrie's decade-long journey, from concept to capable real-world robot. Valkyrie was envisioned as part of NASA's quest to establish a sustainable human presence on the Moon, Mars, and beyond. The bipedal humanoid form provided mobility and manipulation, well suited for space vehicles and habitats. Equipped with advanced sensory and reasoning capabilities, Valkyrie could take over routine drudge work, keeping astronauts safe and free to focus on explorations. This video will trace Valkyrie's origins and evolution. We will explore the initial vision, early capabilities, incremental improvements, and deployment milestones that transformed Valkyrie into a functional real-world robot. This journey illuminates the rigorous engineering process required to progress from futuristic science fiction concepts to operational robotic systems for the harshest environments. The humanoid robot Valkyrie has come a long way since NASA first unveiled the early concept in 2013. Through design improvements, rigorous testing, academic partnerships, and real-world deployment, Valkyrie has been transformed over the past decade into a highly capable robotic platform. This robot's journey epitomizes the engineering process to develop advanced robots for operation in space and hazardous environments. The origins of Valkyrie trace back to the earlier Robonaut program at NASA's Johnson Space Center. Robonaut developed robotic torso technology for working inside spacecraft and assisting astronauts. Building on this experience, Johnson Space Center engineers conceived a Robonaut-inspired design with the mobility of two dexterous legs. This concept aligned with the goals of the Defense Advanced Research Projects Agency's DARPA Robotics Challenge, which aimed to spur development of robots for disaster response scenarios. In 2013, NASA officially entered the competition, revealing their entry. A robot named Valkyrie, standing 6 feet tall and weighing nearly 300 pounds, Valkyrie cut an imposing figure. The humanoid robot had two articulated arms, with hands capable of dexterous grasping and manipulation. Two legs with 5 elastic actuators, each enabled a range of bipedal motion. A sensor-laden head could swivel and tilt, providing stereo vision and depth perception. Valkyrie's design supported operation in environments designed for humans, like space habitats and work sites. This distinguishes Valkyrie from four-legged robots, better suited for uneven terrain, but lacking fine motor control. The Johnson Space Center team constructed Valkyrie extremely quickly, just 9 months from concept to completed robot. They utilized an approach with engineers across disciplines, working together rapidly to meet the deadline. The team worked in 2 long shifts, 22 hours per day. This rapid prototyping mindset allowed Valkyrie to begin real-world testing relatively quickly, identifying improvements for the next iteration. His hurried schedule led to some initial limitations, like unrefined locomotion. In 2014, Valkyrie competed in the Defense Advanced Research Projects Agency's Robotics Challenge trials, navigating obstacles, using tools, and driving a vehicle. The trials identified deficiencies in Valkyrie's walking ability and autonomous decision-making. Valkyrie's first halting steps showed room for improvement in balance and gait. The Johnson Space Center team collaborated with the Florida Institute for Human and Machine Cognition. This helped to integrate a more advanced walking algorithm, called DRC-Loco. This software mediated the interplay of Valkyrie's leg motors, allowing smoother walking. The trials also demonstrated that Valkyrie lacked the onboard intelligence to interpret complex sensory data and make choices. To enhance autonomy, Johnson Space Center partnered with robotics labs at MIT and Northeastern University. The academics developed algorithms that improved Valkyrie's ability to analyze its surroundings and activate behaviors accordingly. These upgrades enhanced Valkyrie's mobility and reasoning skills. But testing also uncovered ongoing hardware issues, like overheating motors. Competing simultaneously in the trials and upgrading Valkyrie highlighted the difficulty of refining a robot with tight timing constraints. In 2015, Johnson Space Center entered multi-year partnerships with Northeastern and MIT, loaning a Valkyrie robot to each university lab. These agreements gave academic robotics groups access to cutting-edge NASA technology to advance capabilities. Northeastern's work centered on prepping Valkyrie for NASA's Space Robotics Challenge. This involved developing skills like repairing habitats and repositioning solar arrays that could aid future Mars exploration. MIT focused more on pushing Valkyrie's manipulation abilities. Students programmed fine hand and arm movements to enable detailed grasping and object manipulation. This built capacity for intricate work, like switch flipping and wire connecting. Throughout 2015 and 2016, these university collaborations yielded major leaps for Valkyrie. Walking, balance, arm control, grasping, autonomy, and sensory interpretation all improved dramatically. Northeastern and MIT freely shared advances with Johnson Space Center engineers, mutually benefiting Valkyrie's progress. Collaborating with external robotics labs enabled big strides in a short time frame. It also provided real-world validation. Valkyrie was mastering capabilities necessary for functional deployment. Equipped with enhanced mobility and reasoning abilities, Valkyrie was ready for a major milestone. In 2017, NASA announced an innovative robotics partnership with Woodside Energy in Perth, Australia. The goal was evaluating Valkyrie's remote operation capabilities in industrial facilities like offshore oil rigs. This built on a 2013 demo, where Valkyrie shadowed human operators at a Trimble navigation facility. The Johnson Space Center team journeyed to Perth to deliver Valkyrie and train Woodside staff on setup and operation. Officials celebrated the launch of this international public-private collaboration in robotics innovation. From 2018 to 2022, Valkyrie underwent extensive trials at Woodside's onshore and offshore sites. Johnson Space Center and Woodside piloted techniques for long-distance inspections and maintenance. They honed semi-autonomous navigation and environment, identifying problems. Valkyrie then performed repairs, like valve tightening, directed by remote human supervisors. This deployment generated huge amounts of data on Valkyrie's strengths and limitations in real working conditions. It uncovered challenges, like enhancing camera and sensor operation in low-light offshore facilities. This feedback was invaluable for NASA in developing robust robots for space. The 5-year Australia collaboration represented a huge accomplishment. Valkyrie proved its mettle in the field, showcasing how far robotics had progressed in less than a decade. After returning from Australia in 2022, Valkyrie entered another stage of upgrades at Johnson Space Center. Engineers integrated lessons from offshore piloting to improve autonomy, mobility, manipulation, and remote operability. Some improvements were lightweight composite materials for arms and legs to improve movement energy efficiency. New sensors and reconstruction algorithms optimized for low light and confined space navigation. Improved grippers and software for manipulating a variety of objects with less human oversight. Faster onboard processors to enable quicker situation analysis and reactions. Valkyrie's journey so far has taken it from lab testing to offshore piloting in just 10 years. This is a remarkable arc only possible through relentless collaborative innovation between NASA, academia, and industry. University partnerships enabled huge capability leaps. Real-world deployment provided critical field insights to refine designs. Competition pressures also spurred rapid prototyping. Each stage of Valkyrie's development fed into the next. The next generation model will build on past success to extend the robot's capabilities. Meanwhile, Johnson Space Center continues advancing complementary humanoid systems, like Robonaut. Applying insights across programs will maximize robotics progress. The evolution of Valkyrie informs the broader quest to develop robotic assistance for deep space exploration. Valkyrie also pioneered soft robotics materials and a distinctly humanoid form. This established pathways for future robots, specialized for human environments in space and on Earth. Through this odyssey, Valkyrie has emerged as an immensely capable robotic platform. Future Valkyrie models will build on these successes to aid astronauts on the Moon, Mars, and beyond. The robot's ongoing evolution exemplifies the rigorous engineering needed to transform futuristic visions of humanoid robots into reality. Valkyrie's decade-long journey reveals the relentless innovations required to develop capable humanoid robots. Driven by NASA's Johnson Space Center's vision, Valkyrie has progressed from an ambitious concept to a sophisticated robotic platform, ready for real-world deployments. Each stage of Valkyrie's odyssey provides insights to improve the next iterations. Competition pressure accelerated initial prototyping. Academic collaborations enabled rapid capability enhancement. Offshore energy trials validated real-world viability while uncovering new areas for growth. By building on past successes, the next generation Valkyrie aims to unlock new possibilities for human-robot teams in space. Valkyrie's story provides a template for robotic systems that exceed human limits. Partnerships between NASA, academia, and industry can realize immense progress in short timeframes. There is still work ahead to prepare robots for the harsh realities of space. But Valkyrie has laid vital groundwork to enable humans and robots to explore the Moon, Mars, and beyond together. That is the current update on the NASA Valkyrie humanoid robot. Go ahead and share your thoughts in the comments. Don't forget to click the notification bell so you never miss out on the newest updates in the world of AI. We are highly interested in your feedback and how we can improve or bring additional topics of high interest. Remember, every like, comment, and share brings us closer together as a community. Until next time, stay curious, stay passionate, and most importantly, stay awesome. Thank you for watching. This is Make Money AI signing off.